Hey, welcome back, my fabulous students. We are going to get into this discussion about behavior of polynomial functions, how to find zeros, how many zeros it may have, just kind of by looking at it, and the extrema or turning points, okay? And so at our school, we've coined some fun little terms. I promised you, dance jam this week. Last week it was a song fest in my classroom as we learned how to sing the quadratic formula. So if you missed that, I'm sorry. And if you, want your own private concert, we can make that happen. So we are going to take a look at how a wiggle, happens. Be right back. One sec. All right, I'm back. All right, a technical extravaganza of things. Okay, so at our school, we are going to talk about a wiggle as being kind of a shape that looks like a cubic function. Okay, so it has sort of cubic function behavior. All right, and then we're going to talk about a bounce, bounce, as being kind of a situation that has quadratic behavior. All right, and last but not least, a cross, bounce, wiggle, cross, is going to be what happens with a kind of a linear factor or linear behavior. And we're going to take a look at how all of these situations create zeros of the function that help us to talk about things like multiplicity and how many roots or how many zeros are applied to the function given the behavior at that particular place on the x-axis. Okay. And the other thing that we want to talk about is kind of the behavior of these functions as x goes to infinity or gets larger and larger, right? And its behavior as x goes to negative infinity. And for my classes, we've talked about this a little bit. So let's just talk about behavior and what we can tell by looking at the degree of the function, okay, and the a value. So in terms of this picture right here, we are starting, all right, with a polynomial function that is an even degree. And we can tell it is going to be an even degree, not even symmetry, but an even degree because of what we see in terms of its behavior. Okay, so this particular function has an even degree and it has an a value that is going to be greater than 0. So it is opening up. And we know it has an even degree because as x goes to infinity, I can see that my f of x value or my y value is also going to infinity. So that's what you would say as your x value is increasing, getting larger and larger, your y value is also increasing, getting larger and larger, or your f of x value. And then you could say as your x value gets smaller or goes to negative infinity, your y value is also going to be going to infinity. So this is an opening up on the left-hand and the right-hand side of the graph. And specifically the cubic behavior I wanted you to see right here was this cubic behavior right there. That's going to be a wiggle. Okay, see how it looks like a cubic function right through that space? All right, we'll talk about what that means in just a minute. All right, let's go on. Okay, kind of keep looking at these graphs. And what we see here is another polynomial function. The end behavior here is it's opening down. So it's still an even function. So it still is going to have an even degree. And you can kind of tell that also by the number of zeros it has across this quadratic bouncing behavior right here, which is actually going to be a double zero. So it's going to be 1, 2, 3, 4 zeros that I can see right here in my polynomial function. So I know it has an even degree. I know the a value is going to be not greater than 0 for opening up, but less than 0. So it's going to be negative, and it's going to open down on the left and down on the right. And so the way we talk about that behavior is going to be as x goes to infinity or gets very large, the y or f of x value in this case is going to go to negative infinity. Okay, and as x goes to negative infinity or gets very small, my y or f of x value is going to go to negative infinity as well. So this helps us to talk about, for example, the domain of our function. What is our domain going to be? And then what is the resulting range, right, going to look like? So all of these behaviors help us to analyze our polynomial. And again, this idea of a bounce, where I have behavior that is quadratic, is happening right here. This is a bounce. It's where it comes and touches our x-axis and then rebounds off of it, either from the top or it could happen from the bottom as well. So that's going to be a bounce. That's going to be our quadratic behavior. All right? All right, let's keep going. Here is an example of a polynomial function that has an odd degree. Okay. I can tell it is going to be an odd degree polynomial function for a couple of reasons. One, I see across, across, and across right here on my x-axis, giving me 3 zeros, which helps us to build an odd degree polynomial function, probably a cubic. Another reason I know it is an odd degree polynomial function is because it is dropping to the left and rising to the right, and it's not a both open up or both open down situation. Okay, so for an odd degree polynomial with an a value that is greater than 0, the behavior is going to always be like this. The behavior for this scenario, odd degree, a value greater than 0, which means it's positive, is as x goes to infinity, your y will also go to infinity, and as x goes to negative infinity, y or f of x will also go to negative infinity. So this is your behavior for your end behavior for your graph of an odd degree polynomial with a positive leading coefficient. There you go. Which brings us to the last one with all of these. Look at how many times it's crossing. So the crossing behavior is it's like just shooting right through, like a straight line would shoot right through, and there it is. It's crossing, 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 crossing. So these are all potentially zeros of my function. Look how many of them there are here. 1, 2, 3, 4, 5. I could potentially have a fifth, at least a fifth. It could be a 7th degree or a 9th degree if I had some imaginary or complex solutions kind of thrown in the mix. But what I know for sure is I know it's going to be an odd degree polynomial function. So I know it's going to have an odd degree. And I know by looking at this picture, because it's up on the left and down on the right, that my a value is going to be less than 0. It's kind of like going down from left to right across my graph. And so my behavior is going to be as x goes to infinity, y goes to negative infinity this time. It kind of switches up. And as x goes to negative infinity or gets really, really, really small, my f of x or my y values will go to a positive infinity. Okay, so here's my odd degree. That's going to be the behavior. And my crossing is going to look like this. It's shooting through that x-axis. Okay, and that is a linear behavior. Okay, and I can see 1, 2, 3, 4. Look at those 5 zeros that I might be able to use to build my function. I could just pull them right off of the graph right there. Okay, so let's try doing that. Let's try analyzing a function together and kind of see how this goes and what problems you guys might be tackling with respect to behavior for your polynomial functions. So let's roll on down the screen here. Kind of remember our bounce, wiggle, cross, and our linear factors and everything that we've learned so far about what could happen with this polynomial. So we're going to start here with just a little example of a -1. I can see this -1 right there. There's my negative. And I have 3 linear factors, which means I have 3 zeros of my function. So it looks like I'm going to have 3 zeros. The degree of this polynomial function, if I were to graph it and multiply all these together, I would have an x cubed, right? So it's going to be a cubic function. That's going to be my degree of my polynomial function. And then the end behavior, because it is odd and because my a value is equal to a -1, my end behavior is going to look something like this. I would know that it was going to be up on the left and down on the right. That is going to be my end behavior. So it could do something crazy in between, like crossing at a -2, probably crossing at a 1. It looks like 4 is my other 0. 1, 2, 3, 4. So my arrow is going to be over here a little bit more. So my graph is going to look something, oops, which way did I go here? What just happened? Oh, I know what just happened. Time. Okay, let's try this again. I have my zeros, and if I can get them all in the right spot, we'll go to town here at -2. Okay, let's try this again. So it's going to go passing through here, and then passing through my 4. That looks better. So the end behavior, you would say, right, as x goes to infinity, y goes to -infinity. As x goes to -infinity, y goes to infinity. And so you could write that information about your end behavior based on what we just saw. Okay, why don't you stop for 2 seconds. Stop the video. Try M and N. I'll write the answers in, but you got to stop for a minute first and see if you can do it on your own. Okay, I'm back. Hopefully you paused. Look at all this new information that has just popped onto your screen. And hopefully you're seeing zeros here, right? It's x minus a -2, so -2 is a 0. X minus 3, so 3 is a 0. And x minus 1, it's cubic. It's an odd degree polynomial function. This is what you should have written down for the behavior because 2/3 is positive. It's up on the right, down on the left. And then I didn't quite finish this one up because I thought we could finish it together. These are the zeros you should have. A 4th degree quadratic. This -1 right there means it's going to be opening down. So it should look like this. It should zoom through here, just like that. And as x goes to infinity, y should be going to -infinity. And as x goes to -infinity, y should also be going to -infinity. How'd we do? Did you guys get that? Is it coming along? I hope it is. I hope it's going great. So let's take a look at this crazy picture talk a little bit about multiplicity, and then that is going to be a wrap for this video on behavior. Okay, look at this one. This one is awesome. Okay, first of all, I love this picture because it has a bounce, right? It has a wiggle, and it has a cross. All right, so I picked it especially for you guys because it has all of these things. Okay, so let's look for the bounce. Dun, 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 dun. Here's the bounce at -1. That means that the multiplicity in that space at a 0 of -1 is 2, right? Anytime it bounces, that's going to be a double 0. All right, so we are going to have a factor of x minus a -1, and that is going to happen twice. So its multiplicity is going to be 2. My multiplicity. Maybe I'll write it. Let me write it back here a little bit different than this. Okay, so a multiplicity. Big, long, crazy word. Multiplicity here is going to be 2. And it is going to have 2 zeros. There we go. We'll get a column for each. Okay, this graph also has a wiggle. There it is, right there. Here this wiggle is happening. It's cubic behavior that's happening at x equals 2. So that means it's going to have 3 zeros. The multiplicity is going to be 3, and my factors are going to be in x minus 2 3 times. That's going to be the multiplicity for this polynomial function. What? That's crazy. Don't forget we have an a value and a y equals here also. So we're building this function. Okay. What about the last one? Here's the cross. It's crossing right through. It's linear behavior. It's crossing through that 4. So it's going to have 1 0. The multiplicity is 1, and it gets one factor, just an x minus a 4. And that's it. Now, if we knew a point on this graph, right? If we wanted to pick some point on this graph, like maybe, I don't know, 4.3 negative, let's say 4.3 comma -4. Okay, maybe that is a point on our graph. Then we could use that point, if we knew for sure that that was a point on our graph, in the place of x and y to solve for a. I don't know that that's a point on my graph, but what I do know about my a value, look at your graph. What do you think has to be true about your a value? You guys should be like talking to the screen right now. This polynomial function is an even degree polynomial function. Let's count them up. 1, 2, 3, 4, 5, 6. At least a 6th degree polynomial function is what we're looking at here. And what else has to be true? At least a 6th degree. And because it is opening down, the behavior is down to the left and down to the right, my a value has to be, that's right, you got it, less than 0. It has to be negative. So I can tell a lot about this graph just by finding my double 0, my cubic behavior, my linear behavior crossing at 4, writing all of these factors, and knowing that this a value, yes indeed, is going to be negative. Okay, so a couple things to remember. A polynomial of an nth degree can have up to n-1 turning points. So if this is a 6th degree polynomial function, the number of maximums or minimums or extrema it possibly can have is going to be n-1, okay, turning points or extrema. So that's going to be an important piece to kind of keep in mind as we go forward. Here's a turning point 1. There's one 2. There's a turning point 3. There's one right there 4. Okay, so it has 4 kind of turning points. These are local maxes and mins right here as it turns. One right there, one right there. That's going to be a local max. This is a local min. You guys probably can't see it because I'm tracing over things. Here, let me use a different color. So that's a local min right there. This is going to be a local max. This is going to be a local max. Okay, top of my hill. And then I just included this other little piece of information that we already kind of talked about. It's kind of some formal language if you'd like to stop the video and read through it. Has to do with the multiplicity that we just talked about and how to build a factor. Okay? Basically x minus a, we've been calling it x minus h. So no worries there. You guys have been doing such a great job. This is kind of a long video, 20 minutes. Woohoo! All right, we will practice these and bounce, wiggle, cross ourselves through our next time together. All right, it's going to be a major dance jam. Have a good day, guys. Take care.